Hi, and welcome to another Coding Casual video. Now, have you ever seen art that sort of looked like this, or like this, where you just have a whole lot of paint in different swirls and different colors? The whole thing looks pretty chaotic. It's really a mess, but you can see different techniques. Some of the lines are just like drawn, and then others are like just splattered and drizzled onto the canvas. Now, if you have seen art like that, you are most likely looking at something that has been drawn by Jackson Pollock or somebody trying to imitate his style. Now, Jackson Pollock was an American artist who lived in the first half of the 20th century, and he really got famous for this particular style of art. Now, if you go to openprocessing.org, which is a homepage that I can absolutely recommend to you, you can find a sketch called Pollock with 3 exclamation marks by someone called Ricardo Luis. And if you now move the mouse across the canvas, we can now see a piece of art forming in front of us, and we are really controlling how everything is working here. So we have some kind of brush following our mouse, but it's not following it perfectly. It's sort of lagging behind, which means we can draw perfectly round, perfectly smooth swirls of paint here. And notice also that the thickness of the line that we are drawing changes depending on how quickly we are moving the mouse around and whether or not it's staying in one place or not. And this really gives us this impression of this really being paint that it's being used and not just some pen that's moving across some piece of paper here. And in addition to that line being drawn, so that brush that we have here, there's also just stipples and little drizzles of paint happening all over. And if we just go crazy here and paint more and more, then we have a Jackson Pollock like image forming in front of our eyes. And today we'll try to recreate that ourselves in processing using the Python mode of processing. Now, bear in mind that processing, the way it was originally developed in JavaScript, it was not developed to be used by computer scientists. No, it was developed with artists and designers in mind, and people who want to do artsy stuff with code. And I think it's just fitting for us to have one video where we'll just create some art and not some game or some math or science related thing here. But for once, let's just create some art and try to write that from scratch using the Python mode of processing. Okay, I'll always try to start out with an empty script, but today I have something here already, which is a list called colors, and in this list I have a bunch of tuples with 4 values in them. And these 4 values, red, green, and blue, and then transparency, these are different colors. And I didn't want to type out, spend the first 5 minutes of the video just typing out these values. So just feel free to copy them from my sketch. I'll link to it in the description of this video. And with that in mind, we can already start. I'm importing processing, obviously, and then I'm importing from the random module the shuffle function. And the first thing that I'll do is I'll shuffle the colors. So let's do that and print them out. Let's run this, and we can see we have our colors here. And if I run this again, you can see that they are now in different order, and every time we do that, they are shuffled differently. But it's always the same. It's always the same set of tuples. Now, anyway, let's have our setup function. Define setup. I'm gonna have we can actually use uppercase. Let's just use uppercase letters here. We'll shuffle this, and we'll have a width which we'll set to, I think, 400, and we'll set the height to 400 as well. And then we have to say shuffle colors, and then in setup, we'll set the size to width and height. We'll then select a base color, which will be the background color, but I can't call it background because background is not really the function background, right? So I'm just going to call it base, and we'll just pop from our colors one of these colors. Now, if you feel like this is not really a constant, this is why I was sort of hesitant to use uppercase letters here. Let's just, make this colors maybe like this. And then we'll use this base color to color our background. So we'll now use the actual background function. We'll select base 0, and then base 1 and base 2. We don't need a transparency here because, we don't want the background to be transparent, right? And then we'll have our draw function. Nothing goes into here right now, so this is just a pass. And then we have, well, not another define, but we have the run. So let's run this. And there we go. I mean, we don't need the console anymore. Let's bring this down here. Run this again. We now have our canvas. And every time that we run that, we have, the chance of getting a different background color here. Okay. The first thing which we'll now use is a brush, which we can use to have swirls of paint up here. So nothing like, the stipple effect or the drizzle, nothing like that, just the brush that we can use to draw stuff onto the screen. And we'll want to have this ability that the brush is not exactly where the mouse is, but somewhat behind it. Now, if I move the mouse down, it's now going to create a smooth curve instead of this being a hard line. And we can do that by defining a brush, and we'll do that up here. And this brush will now be a dictionary. I mean, we could also make it a class, but I've used classes in the previous two videos where we had a little physics engine and then the doodle jump game, but now we'll use a dictionary. And in Python, these are defined where you have to have a combination of some name, which is a string, and then we have to have a value. And right now, I'm going to make this string going to be x, so we have a certain something called x, and we'll just initialize it to none. Then we have a y, which will also be none. And then I'm going to use two other things called px and py, which are the previous values of x and y. But right now, they are also just none. So we'll have that object. Okay, next, let's go into our draw function and refer to that brush. Okay, now, if we start drawing right off the bat, and let's say we had initialized this to 0, then we would always start in the top and then draw somewhere onto the screen. And we don't want that. Sometimes we want the user to start right here or right there. So what we'll do is we'll say if the frame count is equal to, let's just say 50. So the first 50 frames of the animation that are happening right here, nothing's happening in terms of the brush. But once we are at the 50th frame of our animation, of this animation loop here called draw, so the 50th time running this is where something happens. So we'll take our brush object, put it down here, and we'll now say, well, in this case, we'll set this to mouse x, mouse y, and then we'll just say mouse x minus 1 and mouse y minus 1. And then we'll say else. So in all other instances, that is, we are, well, not else, because this would also refer to frame count being less than 50. So else if frame count is greater than 50. Now in these cases, this is where the magic will now happen. So the first thing is we'll update the brush x value, and we'll set this to the difference between mouse x and where we had been before, but we'll divide that by 12 just to make sure that it's not changing too quickly. And then we'll do the same thing with y, and mouse y and y down here. Okay, once we've done that, we can now call a function which we have not defined yet, which I'm going to call drizzle. And then we'll have the brush px and py, which we now have to update. So py, let's make this x, px, this is equal to brush x, and here we are now updating py to y. Okay, drizzle is not defined yet, so we can't really use that. But down here, let's just define it for the moment with it just being a pass. And let's see if that works. So let's run this. Let's wait a while until we have 50 frames having passed. No error, so I think we're fine. This is working. Now let's introduce the drizzle function. Now let's keep it simple for now and have a fixed stroke weight, not width, of 5. So it's always going to be the same thickness really. Then we have to define a color. Let's just add some space down here. Color, I'm just going to use 0 for the moment, which is just black. And now we'll draw a line which originates at px/py. So we'll use brush px/py and goes to brush x and brush y. There we go. So let's run this. And this started at 0. This is not working the way that I wanted it to. So there's probably a simple little mistake, and that mistake is right here. This has got to be plus equal and plus equal. Let's run this, and there we go. So we now have the brush following the mouse, and you notice that I was able to start right here in this location. It did not always start at 0, 0, but I was able to move the mouse at first, and then it started drawing. Okay, to make things a little bit more interesting, we'll now add a second line being drawn. And if we start up here, we'll then have the other line start down here. So it's sort of going to be the mirror image of what the black line is. Let's go into here, and we'll now say that we have another line, which is white. So we'll set this to 250 now. We'll take this, and now we'll say that we're not drawing at px. So this will be different now. So we'll say width minus px, and here we'll say height minus py, and then the same thing with x and y. So width minus that, and height minus that. So let's run this, and there we go. We now have 2 lines, and this, this is just makes it easier to get stuff drawn to the screen because we are now drawing at twice the speed, and this is how the original sketch, which I'm copying here, had things happen. And yeah, next thing will be for us to change the width of the strokes here, right? Right now it's always 5, it's always the same. And we want to make sure that if we are moving the mouse quickly, then it's a thin line. But if we are not moving it quickly, more slowly, more paint is dripping, is running down our brush and going onto the canvas here, really. And this means that the line will then be thicker. Now we got to measure how quickly we move the mouse, or not really the mouse, but how quickly the brush is being drawn across the screen. And we can do that. I'm just going to stop here, stop the animation here. So we'll define a variable called d, which will be the distance that we have drawn this. And the distance function is the Euclidean distance, which you all know from high school, is pre-implemented in processing. So we'll just have to use dist here, and then we have to say from where. So we'll use pretty much all of this and just throw it into here. And we have px, py, x, and y. This will now compute the distance between these 2 points. And then we'll say that the stroke weight, we're just going to call it s, that is equal to, we'll have minimum here, so minimum 15, and then we'll say 1 plus 30 over, and then d plus, and I'm just going to add a very small value here. Now what's happening here? Now d is in the denominator. So this means if d is very large, then the stroke weight is going to be very small. That's the first thing. This is the denominator. And this minimum thing here, this just makes sure that the stroke size cannot grow arbitrarily large. So minimum means we are taking the smaller of these 2 values. It's either 15 or this, whatever is smaller. Okay, so let's run this. And now let's start drawing. So I'm drawing very slowly, and you can see that we have a very thick line. And now I'm going to draw very quickly, and now you just saw that in between we have a very thin segment. And this just gives the illusion of this being actual ink or paint happening here, and not just some computer thing, okay? This is why we just did this the way we did it down here. And I think that's it for the drizzle function. So let's just stop this. So the next thing that we'll want to have in here are just a few stipples of paint. So we'll have another function which I'll call stipple, and then, well, let's make this a pass for the moment, and we'll only want this to happen like every other frame of the animation. And by looking at the source code of the sketch by Ricardo Luis, I figured that the best way, or like a super simple way to do that, is using the mouse moved function, which just tracks the movement of the mouse. And then we can, it doesn't track the movement, it just tracks whether or not we are currently moving the mouse. And here we'll say if frame count, if that is, we're using the modulo operator here, the mod operator, and this says just at every 7th frame of the animation. And then we'll use our stipple function to have little stipples of paint being drawn to the screen at mouse x, mouse y, and we'll use the color 0, which is just black, So in our stipple function, what do we need? We have to have the brush x, I'm not going to use x and y here. I'm going to call it bx and by, okay? So bx and by, and then the color, which I'm just going to call C. And now, how do we draw these little stipples of paint? We'll say there is no outline, so we'll say no stroke. We'll fill that with C, so we can just specify different colors here. Now we'll say for I in range 2, we'll have, so there will be two things happening here. So, not two things, there's the same thing happening twice. So we'll have a random variable called R, which is uniformly distributed between 3 and 12. So we got to go up here and import the uniform distribution as well. Now we go down here and we now draw an ellipse using that newly created R, and we'll say it's bx plus, and then we'll use uniform again, minus 30, 30. So bx and by, it's not exactly where the mouse is. It's sort of offset randomly a little. And by, plus random minus 30, 30. But this shouldn't be random, this should be uniform. And now we'll use R and R. So it's going to be, well, it shouldn't be R, it should be D really for diameter. So let's just make this D. And let's see if that works. And there we go. So you can now see little stipples of paint, but they're only following one of the two strokes here. So only the black line that's being followed by these little bits of paint here. So let's add that to the other one as well. So let's go down here. And at the same frame counts, we'll say mouse X, but this time not really mouse X, but width minus mouse X, and then width minus mouse Y. And now we'll use 255. Which is white. And there we go. So here you can now see that we have both things happening at once. I mean, you could go crazy, switch up these values. So we could go 255 and 0 here. And now you would have, this happening here. So we have a black line with white dots around it and a white line with black dots around it. But I'm going to go back to the way it was. But, feel free to change that. Do whatever you like with it. And yeah, this is now the stipple function. Now the last thing, and this is going to be somewhat lengthy, but don't worry, it's not too hard. This will be the little splatters of paint that are happening. So when we are moving across the canvas, we'll now have, these are individual circles, but now we want little splatters of paint where you don't have one dot of paint with one spot, but you have multiple spots that are close by near another, near one another, and we'll make sure that they will not always look the same. So there will be an element of randomness to that, but you'll see how this works. Yeah. So let's call this splatter, and splatter we'll also use bx and by here. But you know what? X and Y are not global variables, so we might just get away using X and Y here. Why did I use that? Let's just go back here, make this pass. Let's see. There we go. There's absolutely nothing wrong. I was sort of afraid of using X and Y, but I think it should work just fine because we are all within that, within the environment of that function here. So splatter X and Y. Okay, let's create a random color, RGB. It's going to be the choice of one of the colors. So the choice function is also part of the random module. So choice, and this will just randomly select one of the three, not three, how many do we have? 1, 2, 3, 4, 5, 6. One of the colors is being used for the background. So we have 5 colors remaining. So it's going to be one of these 5 RGB tuples here, okay? And now we'll say that X is being offset by a random amount, uniform minus 15, 15. We'll do the same thing with Y, plus equal uniform minus 15, 15. And now we'll have to add, so as I said, I don't want to have one bit of paint drawn here, but multiple ellipses. And this means we now have to, have a loop here. So for I in range 80, so 80 little ellipses, this is what we'll be drawing here. And every one of these will have their own little x and y. And this is why here I can't really use x and y twice. And we'll just call this outer x and outer y, I think. Outer y. And now we'll say outer x and outer y up here. And now this is sort of the actual x, the inner x within the loop. And here we'll say that we'll take the outer x and the outer y, but now we'll add to that a random offset, which will depend on how quickly we have moved the mouse. So what we'll do is we'll say that we'll take the difference 5 times the difference between mouse x and, well, mouse x and the previous mouse x. And then we'll do the same thing with y. P mouse x and p mouse y. And then we'll multiply that with a normal distribution. You can do that using the Gauss command, 0 and 0.25. So we'll have a 0 mean and a standard deviation of 0.25. And we have to import that Gauss function from the random module as well. And by doing that, we'll now have individual circles, individual ellipses. They will be circles, but each of them will be sort of around the same point, but each will have a random offset, and this offset will depend on how quickly we move the mouse. So this whole thing is going to be looking quite nice. Now we've got to change the size here, and we'll now borrow that same idea that we had before, which is, where did we have that? Right here. So this distance idea, right? So I'm going to copy this down here, but now the distance will really be just the distance between the outer x and outer y, and the inner x and the inner y. And now the size, this will be equal to, and I played around with these values to make it look nice, 10 and 150 over d plus, and now again this idea of adding a super small value, I did that up here and I think I didn't even explain it right. The idea is that, well, if you don't move the mouse, then you would have d is equal to 0. You would be dividing by 0, and computers, just like mathematicians, don't like dividing by 0, okay? This is now the size, and now we'll, the color will be, again, we had that up here, random choice, but we'll change the transparency. So the transparency will just also depend on how large that circle is going to be. So I'm just going to call this alpha, and this will be 255 minus the size, s times 5. Now we'll come to the actual drawing part, no outline, so no stroke. And then we have to see the actual color. So we'll create a color from the RGB triple, RGB 0, RGB 1, RGB 2. Now we'll select our little alpha here. Now we'll fill using that C, and then we'll now draw the ellipse, X, Y, and the size. So let's run that and actually make use of the function before we run that. So we'll now say splatter mouse X and mouse Y. So let's give it a go, and we get an error, RBG, this should be RGB, there we go. Let's run this, and there you go. So you now see we have these colorful bits of paint here. So let's try to draw a super straight line, and you can see how these splatters of paint follow a straight line pattern. But if I move it like in a more circular fashion, they are just dispersed more widely. And I think this kind of makes for a somewhat realistic impression here. And the last thing that we'll need to do is we have to add that to the mirror image as well. So let's just copy this down here, and then use the same idea that we had before, which is using width minus mouse X and height minus mouse Y. So this should actually be height right up here. And yeah, so let's run this again. And there we go. So yeah, this is it. We have now our own Jackson Pollock generator. If you feel like this is not the real thing just yet, feel free to make your own adjustments to this. There is no the one solution to this. This is not some, physics-based simulation or math or science thing where there's maybe an objective truth or something. No, this is art. It can be whatever you want it to be. So make changes, change it all up, and let me know in the comments. And yeah, please consider subscribing to this channel. And if you like these sort of little projects, also let me know in the comments. They are greatly appreciated. And yeah, see you in another video.